Back at the Amherst kitchen table of Hampshire College astronomer Dr. Salman Hameed, Mr. Universe, for some kitchen table astronomy. And speaking of the kitchen, we've got a chicken-egg situation when it comes to the formation of our galaxies and the supermassive black holes within most of them.
Right, so we have, Monte, talked a lot about the supermassive black holes that exist at the centers of pretty much all galaxies, including
They're like
ours.
the nougaty center of the Milky Way candy bar.
That's right. And in fact, we had recently talked about a supermassive black hole image of the sort of like, the event horizon from UMass telescope as well, of a galaxy M87. But the big question is, well, how did these black holes, supermassive black holes, and these can be in the range of a few million times the mass of our sun to tens of billion times the mass of our sun. So how did they get formed? And they are at the center of most galaxies. And the question is, well, did the galaxies form first and then the black holes right in the center because the galaxies had denser regions in the center that they grew in that way? Or there were these supermassive black holes as seeds around which galaxies formed, and hence the chicken and egg issue. But unlike
Which we still haven't solved officially yet. So how are we going to solve this black hole chicken and egg issue?
I think if you put a chicken or an egg billions of light years from here, I think astronomers will figure out a way on how to test it, what came first. And that's exactly what they did here. So the issue is that normally black holes that we know of, the formation mechanism is that you have these big stars that are much bigger than our sun, 5-10 times bigger than our sun. When they die, they turn into a black hole. And so you can even have a much bigger stars, but you can form black holes about 5 to 100 times the mass of our sun. But as you can calculate, that's still a long way to go to make these supermassive black holes that could be millions or billions of times the mass of our sun. And so that has been the puzzle, and now it may have been potentially resolved.
So is it a chicken or is it an egg?
It's a supermassive black hole. No, so it looks like that there may be another way to form black holes.
Besides the death of a star.
So if you are going to grow to a supermassive black hole, you will need a lot of stars to die as black holes, and they would keep on growing. So you can imagine the mass getting bigger. But you also have a limit to how much growth of a black hole can happen. I mean, there are physical limits as well. There are some limitations to that. But also, it takes time for that many stars to exist, that many stars to die, in order to grow a supermassive black hole. So if you are looking at a galaxy early in the universe, you would expect, and I'm talking about a few 100 million years after the Big Bang. So that's a lot of the James Webb Space Telescope. It has been detecting galaxies around that time. So you would expect at that time the galaxies with supermassive black holes to be relatively smaller in size, because you wouldn't have had enough time to form many stars for them to die. But this is what, so there was a test to that, and some recently, a paper came out, I think in December, November and December, there were a couple of papers that came out that detected a particular galaxy. And there is a whole other thing. This galaxy is called UHZ1, and it is about 13.2 billion light years away. Meaning to say, it existed about less than 500 million years after the Big Bang. So this particular galaxy is very young.
Or very old, depending on how you want to look at it.
Depending on how you look at it, absolutely. And the way they found it, so there is a whole fascinating stuff, because it's very hard to detect these galaxies, but there is a foreground galaxy cluster, which is called Pandora's cluster. It's its nickname. And again, UMass astronomers have also worked on this cluster. The light from this cluster of galaxies, which is a few billion light years away, can lens far away galaxies. So because of gravity can bend light, it can actually act as a magnifying glass. And so astronomers can look at these clusters and see, are we seeing light from faraway galaxies that has been magnified?
So that's amazing. We're using galaxies as telescopes with our telescopes to see even further out into the universe.
Right. So this was a side note because because I think that is just insane that we figured it out to use galaxy clusters to as telescopes, as magnifying glasses. But within it, those magnified galaxies is this one UHZ1, and astronomers looked at through Chandra X-ray telescope. This is one of the great observatories as well, and they found that there is a lot of X-ray emission coming out, which actually tells you whether there is a black hole or not. Because again, the material around black holes get heated up before getting inside the event horizon, and so you can actually get a lot of X-ray emissions in that context. And they knew that this galaxy is far away because James Webb Space Telescope had seen this magnified version. There is a galaxy there, and now Chandra X-ray telescope saw there is a lot of X-ray emission coming from. And when they looked at, well, how many stars are in this galaxy from James Webb telescope, and they found that, well, around roughly 40 million times the mass of our sun. So it's a smallish galaxy, which you would expect because it's early in the universe, because it hasn't grown up yet. Mm-hmm. But when they looked at how big this supermassive black hole is, it's almost similar size in terms of mass. There are a lot of uncertainties, but it's like 10 to 100 million times the mass of our sun. And that does not happen because all the supermassive black holes that exist, including in our galaxy and in M87, those are much smaller compared to the number of stars in the galaxy. Those are like about 1,000th if you look at just the mass of it. Sure, it's called supermassive black hole, but compared to the number of stars that are in the galaxy, which is in hundreds of billions, you don't have that much mass in there. And so here is a case in UHZ1 where the mass of the supermassive black hole is almost comparable to the mass of all the stars that exist at that time, and that is about a few 500 million years after the Big Bang. So there is no way that you can grow this black hole from stars because there haven't been enough stars in this galaxy to grow to this much supermassive mass of a black hole.
Is this leading astronomers to believe that the egg of the black hole comes first and then brings the stars around it? And if so, what causes the egg? What causes the black hole?
Right. So interestingly, in 2017, there was another paper which theoretically predicted the formation of these kind of black holes directly from the collapse of the gas that is forming the galaxy. And
so everything's tumultuous after the Big Bang. Things are trying to figure themselves out, and a collapse of this gas forms, potentially, these early supermassive black holes.
Right, so you have galaxies form like that too, like collapses of these things. And it turns out that you can also have these supermassive black holes form directly from the collapse of gas at the centers of galaxies. So you do not need, so in some sense, you are creating a large seed around which the galaxy is being formed, rather than a small seed of a black hole the size of a star. Mm-hmm. Here, because of gas, you start off with a black hole or the black hole seed, which is a few million times the mass of our sun. And that was predicted from theoretical models, and in fact, they called it outsized black hole. And this galaxy, this type of UHZ1, they now have given it a name, OBG.
Old dirty bastard?
No,
from Wu-Tang Clan?
No, OBG.
Oh, okay.
Original, I guess, B gangster. But anyway, it is overmassive black hole galaxy. And what that means is, as it says, astronomers are pretty good at, hey, let's call it the way you see it.
Let's call it a large millimeter telescope.
And so what that means is that you have a galaxy which has a much more massive black hole than you would expect. And that was predicted. That was the theoretical prediction, that if you have these black holes forming from a different mechanism than just the death of stars, then you would have early on in the universe some of these galaxies where the black holes have already formed, whereas the rest of the galaxy has not grown yet. And so this is, I think this is a really cool way of thinking of how science progresses. You have this question, we have talked about this many times, and you go like, well, yeah, here is a puzzle, and of course there is an answer to it, but can we find out? And when new instruments come out, so James Webb Space Telescope is crucial in detecting that particular galaxy from which we can measure how much mass is there in stars. You can do that. Chandra X-ray telescope that went about 15 years ago up in space, that can actually detect X-rays. And you have theoretical models that can predict, well, if it happened like this, then you should be able to find a galaxy that has a much bigger black hole at the center than you can form from stars. And voila, problem gets resolved. Of course, there are still uncertainties. This is the first galaxy like this, or first OBG that has been detected. And there is one potential issue that can come in, and that is the measuring the exact distance to that galaxy. Because as I mentioned, sort of like this is so far away that this galaxy light started when the universe was only 500 million years old. But maybe we may be making a mistake in measuring distance. So people are actually going to test out. There are other ways to measure distance more accurately. So they will be doing that. But rest of it, here is a way to form these crazy objects in the universe, black holes, not from the death of stars, but from direct collapse of gas into a black hole.
Science is amazing because A, we're using a telescope to use a galaxy to look at a farther away galaxy to learn about a thing that is mind-blowing, black holes, that were only theoretical 100 years ago when Einstein was like, I think black holes could exist, but they probably don't. But comes up with that theory, technology advances, is able to actually, and using UMass telescopes even, to take an image of what surrounds a black hole to prove Einstein's theory 100 years later. It's kind of amazing.
And 100 years ago, we didn't even know galaxies exist. Because there was a big debate whether is it just the Milky Way, the whole universe, or these fuzzy little patches that we see are those, what they called at that time, island universes, like ours own but farther away. And so that debate happened in the 1920s. And so to come from there, and now we are talking about these galaxies like 13 billion light years away. It's absolutely phenomenal. And these questions being resolved by little people on a tiny little planet are going around sort of like, a Milky Way galaxy with a few 100 billion stars, and our sun just being one of them in the outskirts of the galaxy. And we figured it out. I think, kudos to us. We do a lot of terrible things. We keep on doing it. But, sometimes, credit where credit is due. I think we are doing pretty good.